For this activity, we're making size-scaled drawings of the planets and looking at some important information about each planet. You will need one piece of legal-sized paper, that copy paper that's longer than normal, or two pieces of regular copier paper taped end to end. You will need some circular objects of different sizes to trace and colored pencils. I'm going to go through each step of the entire assignment with you so you know what to do. First off, your finished project will look something like this. Take a brief look at it so you have an idea of what I'm expecting you to produce. Don't copy it straight from this image though, as there will be a few changes. I made this one a few years ago, and you'll see that there are some changes I tried to cover. What I want you to notice here are the sizes of each of the planets so that you can space them properly without running out of room. If you space them out too much, you may need extra pieces of paper to fit it all on. Also, once you're done with this, do not spend time trying to memorize any of these numbers. This is designed to be a one-page at-a-glance comparison of the planets. At no time will I expect you to memorize these numbers. First, you will need something that's about 6 inches in diameter. A Cool Whip container lid is about perfect. Notice where it is on the paper, not centered, but farther to the left side. I traced about 2/3 of the way around the lid. I'm leaving part of it untraced since my paper is a bit too small and my planets are going to overlap. The second thing to trace needs to be only about 5 inches. A cottage cheese container lid works well. You don't have to trace the same objects I do, but they need to be about the same sizes. So look around your house to find something suitable. I'm only going to trace 2/3 of the way around this lid as well. You will next need something that's only a couple inches across. A Coke can is perfect. You'll need to trace the Coke can twice. You can trace the second Coke can all the way around, as it's the last one and nothing will have to overlap it. You might notice I didn't do a great job tracing my last one. It isn't a smooth circle. That's okay. Planets aren't perfectly smooth anyway. So it's actually more accurate if it isn't perfect. Now, go back and finish the edges of the first 3 circles. Next, find a dime. A dime is a little too big for the next 2 planets. So notice that here I slightly marked the edges of the dime with a pencil. You'll need to leave a bit of space on either side of the 2 dime outlines. Next, draw in 2 circles inside the outlines of the dime. You'll then erase the pencil marks around the dime. You will now use the eraser again, this time as a model for the next planet. Your next planet will only be the diameter of your pencil's eraser. The end planet on the left is so small we don't need to trace it. Just sketch an even smaller circle. Finally, move back over to the right and draw an even smaller circle and a tiny buddy for it. These are the size scales for each of the major planets plus Pluto. We'll now look at each planet individually. For each planet, we will color each planet and look at 5 pieces of data: diameter, distance from the sun, orbital period, number of moons, and a relative comparison of the planet's gravity. We'll start with the planet closest to the sun and move outward. The first planet is Mercury. Shade him gray or light black. Mercury is 4,878 kilometers in diameter. It is 0.4 AUs from the sun. It orbits the sun in only 88 days, and it has 0 moons. The last line says 57 pounds. No, Mercury doesn't weigh 57 pounds. This last line for each planet is going to give you a comparison to what you weigh on Earth. For each planet, I'm going to tell you what a person who weighs 150 pounds on Earth would weigh on each other planet. So if you weigh 150 here, you would weigh only 57 on Mercury. Mercury's small and has much less gravity than Earth. So you aren't pulled down as much, actually weighing less. Keep in mind, though, your weight changes from one planet to another, but your mass does not. Next is Venus. Shade Venus with yellow and brown. We can't see the surface of Venus from Earth, just some sulfuric acid-containing clouds. Venus's diameter is 12,104 kilometers. It is 0.7 AUs from the Sun and orbits the Sun in 243 days. It also has no moons. A 150-pound person would weigh 136 pounds on Venus. Pretty close to the same amount, but slightly less because Venus is a little smaller than Earth. Notice that the second number for both Mercury and Venus is a decimal, a number smaller than 1. We already know Earth is 1 AU from the Sun. And since Mercury and Venus are closer to the Sun, this number must be less than 1. Earth is next. Color it green or brown and blue. Earth is a bit bigger than Venus, 12,756 kilometers in diameter. It is by definition 1 AU from the Sun. It revolves in 365 days, has 1 moon, and again, our comparison for all these is a 150-pound Earthling. Mars is next. Shade it orange. Mars is often called the red planet, but it's really a rusty orange color due to iron in its soil. Mars is small, only 6,794 kilometers in diameter. It is 50% farther from the Earth at 1.5 AUs from the Sun. Its year is 687 days, or about 2 years. It has 2 moons, and you would weigh only 57 pounds on Mars. Notice the weight numbers for Mars and Mercury are the same, even though Mercury is noticeably smaller. This is because a large part of Mercury is made of metal, so it's very dense, heavy for its size. Gravitational attraction is based on both mass and radius, not just the mass. You'll see that I put an asterisk next to the 2 moons line. This is because I want you to remember something special about these moons. We'll talk about it more when we talk about Mars itself, but the book describes Mars's moons as probably being captured asteroids. This is not true. That is an outdated theory. I'm putting this asterisk here to remind you when you look back at this later, there's something important about those moons. Label these 4 planets as inner terrestrial planets, meaning rocky planets. Also label where the asteroid belt should be after Mars, but before the larger planets. This belt exists between 2.5 and 4 AUs from the Sun. Ceres is the largest asteroid, but most are much smaller. All the asteroids together are still smaller than our moon. Jupiter is the giant. It's 142,984 kilometers in diameter. Color it with stripes of reddish, yellow, and brown. Be sure to include the great red spot, a giant hurricane-like storm. Also give Jupiter a tiny ring around his belly. Jupiter lies 5 AUs from the Sun and takes 11.9 years to orbit the Sun. Make sure you get the decimal in there between the 11 and the 9. Jupiter has about 80 moons. At the time of this recording, the current count is 79 moons, with several more possible moons. So I'm just giving an estimate here, as this number frequently changes. You would weigh 379 pounds on Jupiter if you weigh 150 here. For the size of Jupiter, you might guess that the number would be even higher. But remember that since Jupiter is made of gas, it's less dense than Earth is. Saturn is next. We think of it as the ringed planet, but actually all 4 of the outer planets have rings. Shade Saturn similar to Venus, yellow and brown, then draw in its rings. Saturn's rings are visible from Earth because they are made of ice rather than rock, like those of the other outer planets. Ice reflects a lot of light, so we can see that light from Earth. Saturn is 120,536 kilometers in diameter. It's twice as far away as Jupiter, 10 AUs from the Sun. It takes 29 and a half years to orbit the Sun, has 82 confirmed moons at the time of this recording, perhaps more, and you'd weigh 160 pounds on Saturn. Notice how big Saturn is compared to the Earth, but you'd only weigh 10 pounds more. Saturn is made of such light materials, even though it's large, it doesn't weigh that much more than Earth. In fact, if you had a bathtub big enough, Saturn would actually float. Uranus is next. Color it greenish blue. Make Uranus's ring vertical. Uranus is so tilted that it looks like it rolls rather than spins. It is 51,118 kilometers in diameter, is 20 AUs from the Sun, and takes 84 years for its orbit. It has 27 confirmed moons, and you would weigh only 133 pounds on Uranus. Neptune is similar to Uranus, only more blue. It also often has whitish clouds and dark spots or streaks on it. It's only slightly smaller, at 49,528 kilometers in diameter. Neptune is 30 AUs from the Sun and takes 165 years to go around the Sun. It has at least 14 moons, and you would weigh 169 pounds on Neptune. Notice Neptune is slightly smaller than Uranus, but you'd weigh more. That tells us that Neptune is denser and heavier than Uranus, probably because it's farther out from the Sun and is even colder. And even though it's heavier, it has about half the moons of Uranus. It seems like it should be more even, and perhaps it is. But it's very difficult to see moons, even through a telescope, at the distance of Neptune. Label these 4 planets the outer gas giants. They are also sometimes called the Jovian or Jupiter-like planets. Also label the final 2, Uranus and Neptune, as ice giants. Finally, beyond Neptune are a large group of objects called Kuiper Belt objects. Pluto and its relatively large moon Charon are example of the KBOs. These objects are on average 40 AUs from the Sun or more. Pluto has other moons too. Pluto is classified as a dwarf planet, and there are several other dwarf planets that have been discovered in the Kuiper Belt, one of which is called Eris. Another KBO we will discuss is called Arrokoth, or KBO 2014 MU69. There are probably many more that remain undiscovered. Again, your final product should look something like this. Put your name in one of the corners, snap a picture of it, and upload it to Canvas, either paste it into a Word document or convert it to a PDF. Submitting by uploading to Canvas is the only way to get credit for your submission.